we went over this. Probably you learned this in grade 8. But anyways, in math, given in an equation between two fractions, one can cross multiply to determine the value of a variable. So I want to show you how cross multiplying works. It's kind of like if you've never been shown this, you don't even realize you can do this stuff. So does everybody agree that 8 divided by 2 is the same thing as 4 divided by 1? Yeah. Okay. So now, what would 8 equal using this cross multiplying? Well, the way cross multiplying works is if I go diagonally across the equal sign, that's whatever you multiply. So 2 times 4 divided by 1. Does everybody agree that's still true? Okay. The other way, 4. Does everybody see I can cross multiply the 1 up and I get 1 times 8 divided by 2, and that's still correct? So here's some things that you don't realize. What is 2 equal to? Well, did you know that you can do a switcheroo across the equal sign? Meaning, I can rewrite the 2 and the 4 in the opposite spots. Okay, so just so you can see what I'm doing is I'm rewriting the 2 and the 4 in opposite spots. Do you see that's still true, right? Yeah? So now, how do I get 2 by itself? I cross multiply the 1 up, and I get 8 times 1 divided by 4. Now, the whole point of this is you're trying to solve for the number or the variable, in this case coming up. It has to be in the top spot. You cannot solve, for instance, you see down here, the x is in the bottom spot. So you're going to have to do a switcheroo a lot. I call it the switcheroo. It's not a math term or anything. But you'll have to do that a lot. So for instance, what would 1 be equal to? So do you see the 1? Do a switcheroo. So can you picture the 1's on top, the 8's on the bottom? I'll rewrite it for you just so you can see what I just said. And I get 1 over 2 equals 4 over 8. So do you see if I want to know what 1 equals? I'm going to cross multiply the 2 times 4 divided by 8. Do you see that's equal to 1? Okay. So if I want to know what 1/2 is equal to, do you see? In order to make 1/2, what would I have to do? Do a switcheroo. So what would it be equal to? 4 over 8. Do you see that? Okay, so does everybody get the switcheroo? I know the switcheroo, a lot of people have not seen that before. You guys have, but it does help. Okay, so now the rules are you need to have x on top by itself. So x is on top. It's in the right spot, but 7 shouldn't be there. So we go 7 times 90 divided by 3. Does everybody see? That's what I'd be punching into my calculator. And what do I get? 210. So what I'm trying to say to you is you don't have to write all these steps and do whatever. You can just, do you see? Do a switcheroo. Cross multiply that over. Can anybody tell me what x equals? Not the answer, but what I would punch into my calculator. I'm sorry? Not 18. Remember, we're multiplying. We're not adding. Yes, it's going to be 12 times 6 divided by 4, and we get 18 as your answer. Okay, that's what you say. Remember, I said not my answer. I want to know what you're punching in. Yes, 18. Okay. Does everybody see? X is in the wrong spot. Do a switcheroo. Yes? So what does x equal? Tell me what I'm supposed to punch in here, Jace. 12 times 5. Very good. And so what do we get? 6. Okay, does everybody understand how to do that? Okay, because when we're doing the trig, we're going to have to get the variable isolated. So we're going to have to do that trick a lot. So then we have other things like this. This is more just solving algebra that you did. In this case, you can't do any switcheroo tricks. What? Well, because there's more than one x's, right? You can't isolate x in one spot, like one little move. So the only way you can do this is cross multiply this up. So what do we get here? 2x equals, when I multiply the 3 to the other side, what do we get there? Very good. You see you get 3x minus 18 because you're multiplying the 3 times both of the terms there. Okay, move this over. I get negative 8x equals negative 18. Divide by negative, or switch the signs. X equals positive 18. Okay, let's try the next one. We're going to cross multiply this up and that up. So what do we get on the left-hand side? No, x plus 6 is going to get multiplied by the 5. So what do we get? 5x plus 30. And what do we get on the right side? 2x. You see what I did there? Okay, so then 30 equals minus 3x. So x equals minus 10. Notice I'm skipping a lot of steps here. We're in grade 10 now. We can handle this. It's not, you got to show every single step. Okay? I'm giving you a little bit of freedom now. Okay? What about this one? Cross up, cross up. Yes? What do we get on the left side? 6x. What do I get on the right side? Very good. So just got to remember to distribute that to both terms. So then if I move this over, I get 3x equals 12. So x equals 4. Everybody good with that? Yeah? Have you seen this before? Is that a yeah? No? Okay, trigonometry is the branch of mathematics that studies triangles. Triangles. Particularly right triangles. We like right triangles. Trigonometry deals with the relationships between the angles. Don't spell it angels, it's angles. And yes, sides of the triangles. And with the trig functions, which describe the relationships and the angles in general. So from a functional point of view, trig allows for us, or allows for the measurement of inaccessible and difficult to measure objects. It is used in surveying, construction, navigation, engineering, physics, and astronomy. So grade 9, we learned how to solve similar triangles. Similar triangles are triangles that have the same general shape, but differ in size. So the angles are the same, but they're not the same size. So for instance, this is just, I stretched it, or and this is the symbol for similar, this little Enya looking thing. Okay? Like if you take Spanish, or even in French, I think they refer to that symbol. Circumflux. What is that? What is this called? Anybody? Yeah. So what is that called? Enya. That's what I said, right? Yeah. Okay. If you measure the sides of similar triangles, you will find that the corresponding sides are different lengths, but the corresponding angles are the same. Okay. So for instance, this angle, which I show is right, those are the same. This might be, say, I'm just making this up, 30 degrees. So this is 30 degrees, and this is 60 degrees, right? They're the same angles, but they're just different lengths of sides. Okay, so we actually say that the sides are proportional, meaning that any two corresponding sides have the same ratio. So if these are similar, do you remember stacking these? So for instance, AB over DE, which is 6 over 4, is the same thing as BC over EF, which is 3 over 2, which is the same thing as CA, which is 9 over DF, which is 6. Do you see these all reduced down to 3 over 2? They're all the same. Remember doing scale factor and all that good stuff? 3 over 2 would be the scale factor, meaning to go from one to another, you're using a scale factor of 3 over 2. Okay, does that ring a bell? Okay, so when drawing and labeling triangles, angles are identified with the uppercase and sides are identified with the lowercase. So for instance, if I say A, B, and C here, these are angle A, angle B, angle C. Or I could write it as, if I wanted angle A, I could say angle BAC. Do you remember this? If I could also write it as CAB, the other way around, right? And then angle B I could say is ABC. Do you see the vertex has to be in the middle? So if I'm referring to angle A, that would be in the middle there. Angle B would be that, okay? So then the side opposite angle C would be little c. The side opposite angle A would be little a. The side opposite big B is little b. Do you see? That's how I refer to as the sides. So for instance, length AB is the same thing as little c. Or length BC is the same as, they're referring to the same thing, little a. Okay, so just different notations. Very good? Seen this before? No. No, we haven't. Oh. Okay. It's not a big deal. It's just naming it, right? All right. So if triangle HIJ is similar to KMN, find the ratios between the sides. Find the missing sides M and H. So when they give you that these are similar, they're giving you an order, meaning H corresponds with K. Like those angles are the same. Angle I is the same as M, and angle J is the same as N. So the order actually matters. So when we're actually doing this, for instance, if I take a ratio of HI, which is 4, you see HI, which is 4, then I would correspond it with KM. Do you see that? Which is, KM is 3. So do you see I'm getting a proportion right now? It's 4 over 3. Okay? And so we just finished saying that if triangles are similar, then their sides are proportional. So they should all have the ratio now of 4 to 3. Do you see what I'm saying? So if I want to figure out what little m is, you see little m is km. That's this part. So I would have to set up my ratio of hj. Do you see that? hj. So this is going to be equal to hj, which is 8, over kn, which is m. So now we actually have a setup to solve, and we just figured out how to cross multiply and stuff like that. So m would be equal to 6. 3 times 8 divided by 4, which is 6 centimeters. Okay, so we're going to do this again. Okay, so we still have our setup of 4 over 3, but this time we're going to figure out what h is. Do you see h is ij? So let's look at our ij there. Do you see ij is that part? So that means I need to set the ij over mn. Do you see? So ij is h, and mn is 5. So do you see now I have another setup here? This doesn't work out nicely, but that's okay. What is h going to equal? Well, yeah, so 4 times 5 divided by 3, which is 6.6 repeating. Okay, so on your calculator, if it has 6.66666 and the last one is a 7, guess what they did at the end there? They just rounded it. They can only display like 10 or 12 digits there, right? So it really is 6.6 repeating. How do I know that? Because what is 20 divided by 3? Well, 3 goes into 20 6 times and 2/3. And I know everybody knows that 2/3 is 6 repeating, right? So you'd be better off to say 6 and 2/3, or you can leave it as just 20 over 3. now that we get up into the higher rankings here, exact values is all that rules. We shouldn't be rounding unless it actually says to. So we actually just leave it as 20/3, right? Might look like a goofy answer, but that's all we do there. Yeah. So if a tree casts a shadow 6.9 centimeters long, at the same time a golfer whose shadow is 2.3 meters long, I said centimeters for the first one, was meters. Find the height of the tree if the golfer is 1.5 meters long. So we did this in grade 9. You may not remember it, but we did. So tree casts a shadow of 6.9, so 6.9 is here. The golfer is 2.3 is the shadow here. Does everybody understand why I put those labeled there? Because if the sun is way up here, do you see this is casting a shadow on the ground? Yes, makes sense? The shadow isn't in the air, it's on the ground. You see it. Okay, and then the golfer is 1.5 meters high, and we do not know what the tree is. So let's just call it x. X is going to be the height. So can anybody think they can set up this similar triangles for us? So you can see visually which ones you should put over what, because they're the same kind of size. So what would 2.3 be over? 6.9. And that is equal to 1.5 over x. So you might say, well, why would you set it up that way? Well, really, you should set it up with x on top. X over 1.5 equals this over that. It doesn't really matter how you do it. You have your calculator. You can cross multiply. What is x equal to? I got to grab mine. And I think it works out nicely. Yeah, 4.5. Is that what everybody got? Any questions there? Huh? We're good? Okay, next one. If the following triangles are similar, find the lengths of the missing sides. Hint, redraw the triangles. So this was a setup we did in grade 9. A lot of people got tricked by it. Why? Because they don't realize that the big triangle is actually a length of what there? It's 30. 12 is just from here to here. 18 is just from here to here. Do you see? So that's why it says hint, redraw. So you have the first triangle that's 18. This 4, I think it got shifted. The 4 should be here, just so you know. And then we have the big triangle here, and this is 30 and B. So do you see the two triangles? Do you see how you would set it up to solve? So I'll give you a moment to try to set it up and solve there. So we set it up as an equal sign. So if I want to correspond B, I'll say B over 4 equals 30 over 18. So B would equal, say what? Oh, 6.6 repeating again? Yeah, you can. Sure. Well, we can say 6.6. Okay, you could have set it up other ways. Did somebody have a different setup? I'll just show you. Either way, you're going to get 6.6 repeating, right? But you shouldn't round unless it's saying so. You keep the bar or go 6 2/3. Probably when you see that. Whatever you do, don't go this over this equals that over this equals 6.6 repeating. That's not equal. What? How is this equal to this equal to this? B is equal to 6.6. Don't go across, go down, down, right? B is equal to that. It's not everything equals each other. Keep going. Okay, the reason why we would redraw this is why? Why would we redraw the way this is? Yeah, yeah. Like, do you see this right angle is this right angle over here? So it's up to you if you want. Do you know which one corresponds with C? Which one? The 3.8 or the 5.2? 3.8. So it's up to you if you want to redraw. If you can see that C corresponds with 3.8, then you're good to go, right? C over 3.8 equals what? What do I put next? Yes, 14.7 over 5.2. Does everybody see if I start with C and put it over this triangle, then I have to the next one put this first, then that, right? So it takes a little bit of practice if you don't remember this. Oh, it's not even a great thing. It doesn't even. No. So we're going to say C. It should have said this in the directions. C is approximately 10 point, we'll do 2 decimal places, 7.4, and this is feet. Does everybody know when you're rounding, you're supposed to do the wavy equal sign? Yeah? Yeah? No? That means I rounded, right? Or truncated, you could say. You know what truncated means? It's like cut it off at 2 decimal places.